Welcome back to our channel. In today's video, we are going to break down the magic behind the calendars. Alright, let's start with the basics. What exactly is a calendar? A calendar is a system which helps in organizing our days, months, and years. The calendar is the one which helps us in tracking our time, planning our schedules, and even celebrate the important events. But do you know that calendars have a lot of hidden patterns? Let's explore them one by one. A calendar have 7 weekdays starting from Sunday to Saturday, and there are 12 months starting from January to December. This is the basic for every calendar. And now let's talking about something you have probably heard a lot, which are leap years and non-leap years. Firstly, talking about a leap year, a year is said to be a leap year if it is divisible by 4. If the year is a century year like 1700, 1800 and 1900, then it must be divisible by 400. So here it should be a leap year if it is divisible by 4, and if it is a century year, it should be divisible by 400. Here are examples given. 2000. 2000 is a leap year because 2000 is a century year. So 2000 must be divisible by 400. Cancelling the zeros here, 4 ones 4, 4 5s 20. So the remainder is 0. Whenever we get a remainder 0, we say that the number is completely divisible by 400. So when remainder leaves a 0, we consider it as a leap year. Similarly for 1900, 1900 is a century year. So it should be divisible by 400. Zeros gets cancelled, and we know that 19 is not a multiple of 4 and remains some remainder. So when we have a remainder, we say that it's not completely divisible. So we say that 1900 is not a leap year. Similarly, 2024. 2024 is not a century year, so it should be divisible by 4. So when I divide 2024 divided by 4, we get a remainder of 0. So when remainder is 0, we say that it is leap year. So 2024 is a leap year, 2000 is a leap year, and 1900 is not a leap year. Talking about a regular year, which is a non-leap year. A year is said to be a non-leap year if it is not divisible by 4. Considering an example of 2019, we just saw that 19 is not a multiple of 4 and remains some remainder. So we say that 2019 is a non-leap year. Similarly, 2021 and 2023 are considered as a non-leap years. Now, I hope that you can easily classify the leap year and the non-leap years. Moving forward, talking about numbers, a non-leap year have 365 days, which means 52 weeks and 1 extra day. Similarly, for a leap year, we have 366 days, where we get 1 extra day in February. So that means 52 weeks and 2 extra days. These extra days are called as odd days. These odd days are essential in solving the calendar problems. And the formula for calculating the odd days is total days divided by 7. Why only 7? We have how many days per a week? Per a week we have 7 days only. So whatever might be in calculating the odd days, we divide by 7. Months and their odd days. See, we have January. When we say January, we have total number of days as 31. And how to calculate odd days? Just now we saw that odd days equals to total days divided by 7. Total number of days in a January is 31. 31 divided by 7. The remainder is 3. So the remainder which we get is the odd days. Similarly for February, for a non-leap year, we have 28 days. 28 divided by 7. 7 fours 28. That means that remainder is 0. So 0 remainder means 0 odd days. For a 29 days, we get the odd days as 1. Similarly, for March, April, May, we calculate the odd days with the formula total number of days divided by 7. See, just remember that for a month which have 31 days, we have odd days as 3. For a month which have 30 days, we get the odd days as 2. This is a simple trick you have to remember. Moving next. Weekday codes. See, for every week we have a special code. For Sunday we have 0, for Monday we have 1, and Tuesday 2. Similarly for until Saturday. These are the week codes which we have to remember in solving the calendars. Calendars are actually a simple and a short concept, but guess what? Everything about them revolves around only 5 models. Yes, Just 5 models unlocks the entire logic behind how the calendars work. Starting with a very basic concept in finding the leap years and non-leap years. Our very first question is the year 2023 a leap year? We know that a year is said to be a leap year if it is divisible by 4, and if it is a century year, it should be divisible by 400. The given year is 2023. 2023 is not a century year, so it should be divisible by 4. When 2023 is divisible by 4, 4 ones 4, 4 fives 20, and again 4 fives 20, and the remainder is 3. So it is not completely getting divided with 4, and we say that 2023 is a non-leap year. 2023 is a non-leap year. Similarly, we will calculate for every question. Is the year 1200 a leap year? Okay, given year is 1200. 1200 is a century year, so it should be divisible by 400. 2 zeros get cancelled. 4 ones 4 and 4 threes are 12. That means that remainder is 0. So what we say, if the remainder is 0, then it is a leap year. If the remainder is not 0, then we say that it's a non-leap year. I think you are clear with this. Moving next, calculating the odd days. We know that odd days are the extra days which we get after grouping the 7 weeks. And in 365 days, which means that in a non-leap year, we have 1 extra day, and in a leap year, we have 2 extra days. The given question is how many odd days are there in 100 years? Okay, given time period is 100 years. In this 100 years, we have some leap years, we have some non-leap years as well. Okay, let's find out how many leap years are there and then how many non-leap years are there in the 100 years. To calculate the number of leap years, what we do is simply divide the number with 4. We get the leap year. 4 ones 4, 4 twos are 8, and the remainder is 2, 4 fives are 20. So in 100 years, we have 25 leap years. If I say that 25 leap years are there, the remaining all the years are non-leap years, right? Non-leap years becomes 100 minus 25, and the result is 75 non-leap years. So in 100 years, we have 25 leap years and 75 non-leap years. This is leap year and this is non-leap year. We know that in a leap year, we have 2 extra days, and in a non-leap year, we have 1 extra day. So we'll calculate using this. So odd days for 25 leap years is 25 into 2. That means that we get 2 5s 10 and 2 2s are 4 plus 1 5. So 50 odd days we have, and in 75 non-leap year days which we have, 75 into 1 becomes 75 odd days. So in 25 leap year we have 50 odd days. In 75 non-leap years we have 75 odd days. Now adding up these two, we'll get the resultant as 5 here, and 5 plus 7 12. So totally we have 125 odd days. Now what we do, 125 should be a multiple of 7 because a week has only 7 days. So 125 divided by 7. 7 ones 7, 7 ones 7, and the remainder is 5, and 7 sevens 49. We get 17 full weeks and 6 odd days. The remainder here is 6, right? So we get 6 odd days. I repeat again, in the total of 125 odd days, we convert this into 7 because a week have only 7 days. So 125 divided by 7. 7 ones 7, 7 ones 7, and the remainder is 5. 7 sevens 49, and the remainder is 6. So we get that 17 full weeks and 6 odd days. So in 100 years, we have 6 odd days. This is the answer. Our next model and the important model of the calendar's topic is finding the day of the week. In this model, we have to find out the day of the week, whether the day is Sunday or Monday or any other day of the week. What day of the week was 15th August 1947? Okay, we have to find out the day on 15th August 1947. So to solve these problems, the formula which we use is year code plus month code. If we can able to find out the year code and the month code by simply adding them, we get a resultant code. And when we change this resultant code into respective week, we can find out the day of the week easily. So in these problems, we have to find out the year code and the month code. Let's get started how to find the year code and month code. Firstly, starting with the year code. So first we'll solve how to find out the year code. Okay, the given year is 1947, which means that 1947 year is currently running. It's not finished yet. So what we need to consider is the finished years. So how many years has finished? 1946 years has finished. That means simply subtract 1 from the given year. When you subtract 1, what we get? 1946. This is the completed years. Now we'll divide these years into nearby century. Century means what? 1700 is a century year. 1800 is a century year. 1900 is a century year. So what is the nearby century year for 1946? Of course, 1900. So 1900, and the remaining years I'll write as it is. So nearby century year is 1900 and the remaining year is 46. Now what we do is again we divide this century year into nearby leap years. Nearby leap years. Nearby leap year for 1900 is what? 1600. 1600 is the nearby leap year because when 1600 is divided with 400, we get the remainder as 0. So when the remainder is 0, it is treated as a leap year. So nearby leap year is 1600 and the remaining year is 300. So 1600 plus 300 gives the 1900. And again 46 is written simply as it is. Now our next task is to find out the odd days. How many odd days will be in a leap year? There will be 0 odd days. And how many odd days will be in 300? There will be 1 odd day. And for 46, the given year is 1947. 1947 is a leap year or a non-leap year? It is non-leap year. For every non-leap year, how many extra days we have? 1 extra day. Extra day is called as odd day. So that means that 1 odd day is there in 1947 years. So what we do? 46 years are there. No, for every 46 years, we have 1 extra day, which means 1 odd day. So we multiply 46 into 1, which is 46. And then in these 46 years, we have to find out how many leap years are there. To find out leap years, what is the trick we use? We divide with 4. So when I divide with 4, what I get? 4 ones 4 and 6 brings down. Again 4 ones 4 and the remainder is 2. What we need to consider? We need to consider quotient as the leap year. So that means there are 11 leap years in this 46 years. So we add that 11 here. What we get? 0 plus 1 plus 46 plus 11. We know that we have only 7 days per week. So what we have to do? We have to divide 46 with 7 and 11 with 7. Okay. So 0 plus 1 plus 46 divided by 7 and 11 divided by 7. Okay. When I divide with 7, what I get? 7 1 7. 7 6 are 42 and the remainder is 4 here. Again 7 1 7. 7 1 7 and the remainder is 4 here. Okay, now we simplify it into 7 days of a week. Now what we do is we'll add this 0 plus 1 plus 4 plus 4, which what we get? 4 plus 4 is 8 and 8 plus 1 is 9. See, again 9 is greater than 7. What do we have to do? We have to convert the numerator should be less than 7 because we have only 7 days per week. Okay, when I divide 9 with 7, what I get? 7 1 7, 7 1 7 and the remainder is 2. This is the final year code. We just simplified the year so as to get the year code. The year code is 2. Now, what we have to do now? We have to find out the month code. We have to find month code. What is the given month here? August. That means that August is not finished. In August, how many days are finished? 15 days are finished in August. 15 is again greater than 7. We divide it with 7. 7 1 7, 7 2 is 14 and the remainder is 1 here. In January, how many odd days? We have 3. In February, see, since this is a non-leap year, we have 0 odd days. And March, we have 3. April, we have 2 odd days. And May, 3. June, 2. And July, 3. And August, we have the remainder as 1. That means that August, we have 1. By simply adding all this, we get the month code. We get the month code by adding all the reminders. That means by adding the odd days. 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 3 is 11, 11 plus 2 is 13, 13 plus 3 is 16. 16 plus 1 is 17. When I divide 17 divided by 7, what I get? 7 1 7. 7 2 is 14. And the remainder is 3. Remainder is 3. This remainder is the month code. We got the year code and we got the month code. Now what we have to do? Simply add the year code and month code. We discussed it in the first, right? So year code plus month code. What we got? The year 2 and the month code is 3. The total is 5. This is the code. This is the code. Now what we have to do is convert into respective week code. Convert into respective week code. We know the week codes. For Sunday, we have 0. For Monday, we have 1. For Tuesday, 2. For Wednesday, we have 3. For Thursday, we have 4. And for Friday, we have 5. 5 means Friday. So the answer is Friday. 15th August 97 was Friday. What day of the week was 27th November 2017? Same as the previous question. First, we need to consider the completed years, which means that minus 1. 2017 minus 1 gives the 2016. Now we have to divide into nearby century years. Nearby century for 2016 is 2000. So 2000 is the nearby century year. And the remaining years we write it as it is. Now 2000 is itself a nearby leap year, which means that how many odd days are there here? 0 odd days. In 16 years, 2017 is a non-leap year. That means how many odd days we have? We have 1 odd day. That means 16 into 1, which is 16. And we have to find out the leap years. To find out leap years, what we do? Simply divide with 4. 4 4 is 16. And the remainder is 0. We have to consider the quotient as the leap years. So add 4 here. And here is 0. Now 16 is greater than 7. So what we do? Simply divide with 7. When I divide with 7, what I get? 7 1 7. 7 2 is 14. And the remainder is 2. So 0 plus 2 plus 4. Which is 6. 6 is the year code. So for 27th November 2017, the year code is 6. Now we'll calculate the month code. Okay, given month is November. In November, how many days finished? 27 days are finished. When I divide with 7, what I get? 7 1 7. 7 3 is 21. And the remainder is 6. Now we have to calculate for January, February, March, April, May, June, July, August, September, October, and November we get 6. Okay, in January, how many odd days? 3. 2017 is a non-leap year, which means that we have 0 odd days. February 0, March 3, 2, 3, 2, 3 here, 3 here, 2, 3 here. Adding all this, what we get? We get the result as 30. 30 should be divided with 7. 7 1 7, 7 4 is 28, and the remainder is 2. This remainder is the month code. So month code is 2. Now what we have to do? We have to add year code plus month code. What we got the year code? Year code is 6 and the month code is 2. By simply adding that, what we get? 6 plus 2 is 8. 8 is greater than 7. So we divide with 7 again. 7 1 7 and the 7 1 7. Remainder is 1. This is the code. What we know? Sunday is 0 and Monday is 1. That means that 27th November 2017 is Monday. So in this type of process, we can easily calculate the day of the week. Our next question is, if today is Wednesday, what day will it be after 50 days? Okay, they gave the day, which is today, and they asked us to find the day, what it will be after 50 days. Okay, they just say that given days are 50 days. We know that there will be only 7 days. So what we do is simply divide with 7. 7 1 7 and 7 7s are 49. The remainder becomes 1. So what we do is simply add this remainder to the day. Given day is Wednesday, and if I add 1 to the Wednesday, what I get is Thursday. So after 50 days, the day will be Thursday. This looks very simple and easy to solve. So simply divide the given days with 7 and the remainder add it to the given day. Okay, moving next. If 1st January 2022 was a Sunday, what day was 1st January 2023? Okay, first write down the days given. 1st January 2022 and 1st January 2023. So for this kind of questions, what we do is, we'll find out the difference between the years. The difference between the years 2022 and 23 will be 1. And we have to check whether if there are any leap years present between the given year and the end year. If there are any leap years given, we have to add that leap years count. So in 2022 and 2023, we have 0 leap years. So 1 plus 0 becomes 1. This one should be the this one becomes the day. We have to convert it into code. For Sunday we have 0 and for Monday we have 1. That means that if I get the reminder as 1, the day is considered as a Monday. So if 1st January 2022 was Sunday, then 1st January 2023 becomes Monday. So consider the difference between the given years and find out if there are any leap years between them. If there are any leap years, add that leap years to the difference. And we get the week code. This week code should be converted into day, whether it is Sunday or Monday or any other day. If 9th August 1945 was a Wednesday, what was the day on 9th August 1949? The first step is to calculate the difference between the given years. The difference between 1945 and 1949 is 4. Okay, the difference between the years is 4. And we have to check if there are any leap years present between the given year and the end year. In between 1945 and 1949, we have only one leap year, which is 1948. So 1948 is the only leap year which is present between 1945 and 1949. So we add that count to the difference of the years. 4 plus 1 becomes 5. So this is the code for the day. And when converted into the day, it becomes Thursday. So if 19th August 1945 was Wednesday, then 9th August 1949 is Thursday. Moving next. If 25th May was Sunday, what was the day on 12th June? Okay, in this model, they didn't mention year anywhere. So what we do is first let's write down the data given. 25th May was Sunday and we have to find out the day on 12th June. Okay, what we do is we'll consider the month first given. So initial month is May 25. Month is May. In May we have how many days? 31 days. The date given on the May is 25. So what we do is subtract 25 from the total number of days in the month. 35 minus 25 gives 6. What we do is we'll add this 6 to the next date. Next date given is 12. So 6 plus 12 becomes 18. 18 days. But we have only 7 days per week, right? So what we do is simply divide with 7. What we get? 7 2 is 14 and the remainder is 4. So this remainder is added to Sunday. So for 4 days after the Sunday means 1 means Monday, Tuesday, Wednesday, Thursday. When I add 4 days, what I get is Thursday. So 12th June becomes Thursday. So what we do? Initially consider the month. A month have how many days? 31 days. And we subtract the date given, which is 25. We get the result as 6. And we add this 6 to the date of the next one. So 6 plus 12 becomes 18. This 18 days we convert into 7 days. And the remainder here is 4. And after Sunday, we add 4 days, which becomes Thursday. So I hope this is clear. So 12th June was Thursday. Our next model is repetition of calendars. Do you know that calendar years repeat? Yes, the same calendar comes back after a few years. To find out this, we have to check the remainder of the given years. Based on the remainder, we can say the repetition of the year. First, suppose if the remainder is 0, the calendar repeats for 28 years. If the remainder is 0, that year repeats after 28 years. Similarly, if the remainder is 1 or if the remainder is 2, it repeats for 11 years. If the remainder is 3, then it repeats for every 6 years. So this is the repetition of the calendars. If the remainder is 0, it repeats for 28 years. And if the remainder is 1 or 2, it repeats for every 11 years. And if the remainder is 3, it repeats for every 6 years. Coming back to the question, in how many years will the calendar of 2024 repeat? Okay, to know the repetition, we have to know about the remainder. So what we do, 2024 divided by 4. 4 ones 4, 4 5s 20 and 4 6 are 24, which remains the remainder as 0. If the remainder is 0, for how many years it repeat? For 28 years it repeat. That means that 2024 plus 28 years. So that means 8 plus 4, which is 12, and 2 plus 2, 4, 4 plus 1, 5, 0, 2. So the same calendar, that is 2024 calendar, is repeated again in the year 2052. So in 28 years, the calendar of 2024 repeats. The calendar for 2017 will be the same as which future year? Okay, same question. We have to calculate the remainder of 2017. 2017 divided by 4. 4 ones 4, 4 5s 20, and 4 4s 16, which gives the remainder as 1. For 1 year, if the remainder is 1, what we get? For every 6 years, the calendar repeats. That means for 2017 plus 6. 7 plus 6 gives 13, and 1 plus 1, 2, and here 2023. So the calendar of 2017 will be the same as 2023. Our last model is day difference between two dates. Want to count down the exact number of days between these two dates? How many days are there between 15th March 1999 and 15th March 2005? Okay, to calculate the number of days, we have to count the days year by year. That means that from 15th March 1999 to 15th March 2000, how many days will be having? Since 2000 is a leap year, we'll be having 366 days. Again, from 2000 to 2001, we'll be having 365 days. From 2001 to 2002, we have 365 days. From 2002 to 2003, we have 365 days. And for every 4 years, the leap year repeats. So, from 2003 to 2004, the number of days will be 366. Because 2004 is a leap year. And we have to calculate until 2005. So, from 2004 to 2005, we have 365 days. By adding all this, we get the number of days. So, the result will be 2192 days. So, the days between 15th March 1999 to 15th March 2005, we have 2192 days. So, I hope this is clear. Try this question out and let me know the answer in the comment box. Yeah, that's a wrap. Calendars are more than just a dates. They are just about the maths and the logic and the hidden patterns. Now you can calculate the weekdays, we can predict the leap years, and even know when your birthday will fall in the year 2026. If you found this video useful, hit the like button. Don't forget to subscribe for more cool content. And of course, turn on the notification bell so you never miss on the update. See you in the next one. Until then, keep learning.